This is the Analemma, the path the sun traces in the sky above the earth over the course of the year. You may have been introduced to this graph in school. Old maps consistently incorporated this element, usually with great detail. Newer maps curiously seem to leave this component out altogether. Now, imagine if maps began leaving out the compass rose, or latitudinal and longitudinal lines of reference. And this analemma charts the very path of the sun overhead. Maybe there's a clue here that could lead us in the right direction. Shouldn't a ball Earth, undoubtedly having symmetrical northern and southern hemispheres, have the sun form a symmetrical figure eight overhead? So what's the deal with the crossing point being so northernly off-center? Well, authorities claim this variation is due to the fluctuation in speed of the Earth, as it is said to increase as it nears the sun in January and decreases when it's farthest from the sun in June, thus keeping to Kepler's principle of equal area and angular momentum. But looking at the actual alleged orbit of the Earth, which forms a near perfect circle, supposedly, it simply doesn't match the analemma's variation, despite the analemma being in fact how the sun observably travels back and forth between the tropics in its yearly circuit over and around the flat Earth. In fact, so stark is this discrepancy that some modern textbooks have even gone so far as to revise the shape of the analemma into a perfect figure eight, which any navigator would have considered misinformation, an oversimplification of the actual graph. But the analemma, curiously, is not the only thing they've removed from their public curriculum over time.
As an observer on the surface of the Earth, the only indication our planet is rotating is in the observation of the sun during the day and the stars during the night. Every day the sun rises in the east and sets in the west, but we are completely unaware that we are traveling to the east at hundreds of miles per hour. So just how fast are we moving? Well, at the equator, the rotational velocity of the Earth is an incredibly fast 1,018 miles an hour. If you were to travel from the equator to about 30 degrees north latitude, the rotational velocity would have slowed considerably to about 882 miles an hour.